Bismillahirrahmanirrahim. We continue our session 271 lesson with new chapter 3, which is ionic equilibrium. Okay, so this is the outline for chapter 3. We have 3.1, 3.2, 3.3, 3.4. So I will do a very short video for each subtopic for better understanding. Okay. First, we look at the definition of acid and base based on Arrhenius, Bronsted-Lowry, and Lewis theory first. Okay. So we look at the definition first. Types of acid. What is acid and base? Um, Based on Arrhenius, according to Arrhenius or the Arrhenius theory of acid and base, according to Arrhenius, acid is a substance that produces hydrogen ion or hydronium ions in water. So look at this example. HCl is defined as an acid because when we dissolve HCl in water, it will produce hydrogen gas. Hydrogen ion. Similar to the nitric HNO, nitric acid and sulfuric acid. All these three substances dissolve in water to produce hydrogen ion. Okay, one for HCl and nitric acid, two hydronium ion for sulfuric acid. But while base, according to Arrhenius, is a substance that produces hydroxide ion in water. Sodium hydroxide, barium hydroxide, and aluminium hydroxide dissolved in water will produce sodium ion plus hydronium ion. This one, barium ion plus hydroxide ion, aluminium ion plus hydroxide ion. But this theory is limited because it is only applied to water or aqueous solution. It shows that all acid contain hydrogen, but not all substances containing hydrogen are acid. Some substance in the next definition is also acid, but it is not being able to be explained using this theory. The disadvantage of the Arrhenius theory is many organic compounds will not contain hydroxide ion. For example, amine, NH3, and ammonia, NH4, does not have OH in the formula. So it is not show basic property of that substance in water. So it is this theory is limited to explain the acidity and basicity of this of some of the substance. Okay. So we can further improve our definition of acid and base by using Bronsted-Lowry theory. According to Bronsted, acid is a substance that can donate hydrogen ion to a base, while base is a substance that can accept hydrogen ion from an acid. Look at this one. Acid is a proton donor, also called as a proton donor. It will lose its proton or the hydrogen. Look at this one. HCl react with water. So water will receive one hydrogen from the chloric acid. So chloric acid is a proton donor. It donates its proton to the water. While base is a proton acceptor, it gains proton. For example, in this example, ammonia is a base because it accepts one of the hydrogen from water. So in this example, ammonia is a base while water is an acid. But for this one, water will be a base. Yeah? It receives one of the hydrogen from hydrochloric acid. So, unlike Arrhenius theory, which consider liquid and aqueous phase only, Bronsted-Lowry theory can also be used to define acid and base in the gaseous phase. Yeah? Uh, Even though there are no hydronium ion or OH produced, but this theory still can explain the acidity and basicity of the substance based on the proton donor and proton acceptor. Okay, so this one, Bronsted-Lowry acid, donate the hydrogen to a base, while base receive proton ataupun hydrogen ion from an acid. Okay, so that is the Bronsted-Lowry theory for acid and base. And the third one is the Lewis theory. Yeah? According to Lewis, acid is a substance that can accept a pair of non-bonding electrons, yeah? While base is a substance that can donate a pair of non-bonding electrons. Okay? An acid is an electron pair acceptor. It is a positive ion normally. Okay. All cation are Lewis acids since they are able to accept electron. Yeah? For example, copper ion, iron ion, iron 2 plus, iron 3 plus, yeah? Are all acid according to Lewis theory. While base is a substance that can donate an electron pair, and normally all negative ions acts as a Lewis base. Yeah? For example, we have hydroxide ion, nitrile, acetic, acetic ion, ammonium ion, water. Water also can react as a base. Yeah? Water is an acid and also a base. Right? Water is a deuterium ion. It can react as an acid and also as a base. And also CO minus, yeah, carbonyl, okay, ion. So the importance of Lewis theory is it broadened the scope of acid and base reaction by including the reaction which does not involve proton donor or proton acceptor. Yeah? So for example, this one, yeah, Lewis acid is electron pair acceptor. Base is a proton electron pair donor. Okay, so when it's accept proton electron from a base, it can form a bond. Yeah, this one nanti kita tengok ada tak contoh untuk acid base based on the Lewis theory. Okay. Okay, so that is the definition of acid and base according to three chemists, scientists. Now we look at the types of acid and base. Yeah? We have strong acid and weak acid. So what is a strong acid? Strong acid and base is acid and base that are completely ionized in aqueous solution. Yeah? So what does it mean by completely ionized? If we dissolve 1 molar, it will dissociate 1 molar. Yeah? So this is a common example of strong acid. Yeah? We have nitric acid, chloric acid, bromic acid, sulfuric acid. Yeah? While strong base is lithium hydroxide, sodium hydroxide, and potassium hydroxide. While weak acid and base is a weak acid is a substance that partially ionized in aqueous solution. Yeah, and the example of common weak acid is the acetic acid. Saya tengok HCOOH, yeah, fluoric acid, nitric acid. Yeah, while common weak base is ammonia, ammonium hydroxide. Yeah. So this one, if you look at this example, yeah, if you have 1 molar, all substance, ya, all molecule will dissociate. Dia akan terpisah H dengan A dia. We get if you have 1 molar of HA, we will get 1 molar of H and 1 molar of B. But for weak acid and base, it just partially ionized. If you put 1 molar, not all 1 molar will produce H and E. Some of the molecule will still remain as HE, does not dissociate. So that is the meaning by strong and weak. This is very important for you to understand because it will affect our calculation of acid and base, calculation of pH and pOH for strong acid and weak, strong acid and base, and also weak acid and base. Okay, so this is an example of strong acid, weak acid, strong base and weak base. If the substance is a strong acid, when it become a base, it will become a very weak base. Okay. No, sorry, it's okay. This is just example. Nanti yang tu saya akan explain later. In the acid base, acid and conjugate base pair nanti. Okay. So this is just a list of example of strong acid and weak acid, strong base and weak base. Okay. This is another types of acid based on how many hydrogen can be, it donates and how many hydroxide can it donates. So we have 3 types: monoprotic, diprotic, and polyprotic. But normally jarang lah banyak sangat. Normally triprotics je. So this is one protic substance that monoprotic substance that are able to donate only 1 proton. It only have 1 hydrogen: hydrochloric acid, nitric acid, and acetic acid. While for base, of course lah, dia ada 1 je OH. Substance that able to accept only 1 proton. Dia ada 1 je OH. Kalau diprotic, dia ada 2 hydrogen and 2 hydroxide. Triprotic, it has 3 hydrogen and 3 hydroxide. This is a type of acid and base based on how many hydroxide ion and hydrogen ion it can donate and accept. Okay, so I think finish with the explanation of acid and base and also types of acid and base. So this one kita akan discuss in the next slide. Okay.